Hi everyone, this is our first video. This is 1.1, which is angles and degree measure. First thing that we have to talk about, a little bit of geometry. There's kind of a lot of geometry concepts that we'll review like throughout the course while we're going on new material. So the first thing is array. So array is a line starting at one point and continuing in one direction forever. So we have lines, we have line segments, and we have rays. So lines, they go in both sides go on forever. Segments, they stop on both sides. Array is a mixture. So they do start at one point and then they continue in one direction. So also with line segments, regular lines and rays, we always will use 2 points to define these. So I'll call this like AB, and it can go any way. So let's make this one go up this way, and I'll call it AC, something like this. So these are both rays. Now an angle is two rays joined at a common end point, and we call that common end point the vertex. I'll show you some ways that we can draw angles. So let's say I draw this ray AB, and I draw this ray AC. So now we have an angle. The vertex is actually really important because that's usually how we're going to label our angle. There's a few different ways to label an angle. This symbol means angle, so we could call it angle BAC. We could also call it angle CAB, as long as the A is in the middle, the vertex is in the middle. We could also just call it angle A. Sometimes that might not be nice because what if there's another line coming off over here, like another ray, and maybe we call this one D. Well, now if I talk about angle A, do I mean the pink angle? Do I mean this blue angle? Do I mean this whole green angle? So it can get a little confusing depending on the situation. In here, we really won't see too many of those weird cases. We'll see some though, when we do word problems and stuff. Another common way to talk about angles is to call them Greek letters. So we can call this, let's say I want to call it alpha. That's that symbol for alpha. So I could say angle alpha. Some other Greek letters that are really common that we'll see is beta, gamma, and also theta. So these are all Greek letters that we will see throughout this course. So again, your most common ways to talk about an angle is with the vertex in the middle. You can call it just by the vertex if it's convenient, or we can call it by a Greek letter. Also, we always use capital letters. Here, let me go ahead and extend my screen out. Now, angles actually are made up of, since they're made up of these two rays, we can call these two rays different things. So the initial side of an angle is a fixed ray, and it's always the horizontal part. More specifically, when we get into like actually graphing angles and stuff, we're going to see that this is always the x-axis. The initial side of our angle is always going to be the x-axis. Then we have what's called the terminal side of our angle. And this is our rotated ray. And this could be anything. I mean, it could be horizontal, it could be vertical, it could be like a diagonal. So if you're looking at an angle, this part right here, the first ray that's at the bottom, that's your initial side. And then your terminal side is just wherever you draw, like for how big the angle is really. So we could draw it here, we could draw it here, maybe it's down here, maybe it lies on top, like this. So that's all about our terminal side. Now the degree measure of an angle is the number of degrees the terminal side is rotated. I'm going to read that again. So the degree measure of an angle is the number of degrees the terminal side is rotated. So it has nothing to do with that fixed side because that's not going to move. It's always going to look the same. Our fixed side is always going to be here. But the size of our terminal side will determine how, like the measure of our degree. So if I put it up here and it's straight vertical, that's going to be a 90-degree angle. I could put it over here. Oh, sorry, I didn't mean to erase right there. I could put it all the way over here, and I could be talking about this angle. So it just depends. Now, degree measure can either be positive or negative. So if you rotate your angle counterclockwise, then you're dealing with a positive angle. If you go clockwise, that is a negative angle. So counterclockwise is going to be positive, clockwise is going to be negative. And we'll see that when we're actually like drawing them and stuff. So let's see, I'll go ahead and draw our coordinate plane. So, I'm going to draw the XY axis. And I'll label this for us. So, if our initial side is here, that's 0 degrees. Because if I have an angle that like lies on top of that, the terminal side has not been rotated at all, so it's 0. Now, if I rotate my angle all the way upwards, this makes a 90-degree angle, so that makes this 90 degrees. This is also called a right angle, so a right angle is 90 degrees. If your terminal side is rotated all the way straight like this, that is 180 degrees. And so the actual angle here is this whole thing here. So all the way starting at that initial side and ending at that terminal side. That's how big, like that's the actual angle part of it. Lastly, if we put our angle all the way at the bottom, so we're looping around this far, that is 270 degrees. Did not mean to erase my coordinate plane. I just wanted to erase the little arrow, okay? And then lastly, if we come all the way back around to this initial side, but if I had looped around, so if I looped around like an entire rotation, we're going to find that this is also 360 degrees. Now hopefully this should make sense, because if we loop around an entire time, what we're really doing here is we're making a circle. And circles have 360 degrees in them. Also, if we divide 360 by 4, we get 90. And then we add 90, we get 180. We add 90, we get 270. Hopefully this is a review for you, but just in case, I like to still go through it. Some more definition type stuff. We have what's called a straight angle. This is that 180 degrees. We also have what's called quadrantal angles. Quadrantal angles are just any of them that are lying like on the actual like on the quadrant, on one of the axes. So that would be 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. We could actually have more than this. I mean, this could go on forever, because I could just keep wrapping around. You know, I could go here. So then I wrapped around a whole circle plus 90 degrees. I could go all the way starting here, all the way here, you know, so I could actually go even further than that. Just what you have to remember is, remember that the initial side is always here. So this is always our initial side. Something else I'd like to mention is if we happen to go clockwise, so if we wanted to look at like a negative angle, I could go this way, and so this would be negative 90 degrees. I can keep going. This would be negative 180 degrees. Up here, this would be negative 270, and this would become negative 360. So you can also do negative angles as well. Now I do just want to experiment maybe plotting some of these angles. So let's see example 1. I'll just say graph the angles. And we'll do A, let's do 45 degrees. B, we'll do 240 degrees. And then part C, let's do negative 135 degrees. And I'll just graph them on the coordinate plane that we already have drawn. So let's see, 45 degrees. And anytime I do an example, I really do recommend you pausing the video to kind of work through it yourself before I give the answer. So 45 degrees is going to be right in the middle of 0 and 90, so I'll just put it right in the middle here. So that means that this angle right here is 45 degrees. Now let me do 240. So 240 is a little bit past 180, but still before 270. It's a bit closer to 270, so I'm going to put it like right here. And so the actual size of this angle still measuring all the way from that initial side. And then lastly, for 130 degrees, I'll just use pink again. So negative 135. So now I don't want to do counterclockwise like we usually would. I'm going to go I might have said that backwards. We don't want to go counterclockwise like usual. We want to go clockwise for this one since it's negative. So let's see, I'll go 90. Okay, 135 is bigger than that, but it's not quite as big as negative 180. So it's going to stop roughly in the middle of this quadrant. And then I drew that angle for us. Okay, just going to move on. Next, we're going to talk about something called coterminal. So let me write a definition for us. Two angles are coterminal . Oh, let me go ahead and label these, sorry. Two angles, alpha and beta, are coterminal if and only if there is an integer k such that the measure of alpha, that's that notation right there, m parentheses alpha means the measure of alpha, plus 360 degrees times k is equal to the measure of beta. Now this idea here, one, the fact that it's an if and only if is actually kind of a big deal in math. It just means that we can go both ways. So if this condition is met, we can call it coterminal. And then also if we want to, if something is claiming to be coterminal, this should also be true. So it is nice when we see if and only if statements. They're really strong in math. But I feel like this is such a mathy definition, and it really doesn't have to be that complicated. What this is saying is that two angles are coterminal if you can add 360 to them and they still fall in the same place. That's the idea. So let me show you what this does. I'm going to show you on this negative 135 degrees. So for instance, a lot of times we don't like to work with negative angles. They're just kind of they're a little bit harder to plot because it's not as natural. And then also when it comes to solving equations using identities, which we'll do later, the negative angles can just kind of be a pain. What we can do instead is we can add 360 to make it a coterminal angle. The K is just meaning how many times would you like to add 360. You can also subtract 360. That's what makes it an integer. So an integer is just a whole number pretty much, but it can be positive, negative, or also 0. So what we're really saying is, do you want to subtract 360? Do you want to add 360? What are we doing here? If I add 360 to negative 135, I'm going to get 225 degrees from this. Well, if I go plot that, I'll find that it falls in the exact same spot that negative 135 fell. So coterminal angles are really just the same angle. It's just they've been approached in a different way. So maybe one went clockwise, maybe one went counterclockwise, maybe it got wrapped around a little bit. So I'll show you an example of that as well in the next one. So let's do a little example. So this is example 2, and I'll say find two positive angles and two negative angles that are coterminal with negative 50 degrees. So find two positive angles and two negative angles that are coterminal with negative 50. So yes, we could use the whole formula. You know, I could call this alpha and say, okay, let me plug this. I don't know. It feels a little too plugging in and just trying to memorize something. It doesn't really show you what coterminal really is doing. Coterminal just says add or subtract 360. That's honestly all it says. So if we want a positive angle, you want to think, should we add 360 or should we subtract 360? Well, I want a positive angle, so I'm probably going to need to add it. So I'll start with negative 50 degrees, and then I'll just add 360 to that. And that answer is going to give me 310 degrees. So the point of this, like what we'll mainly use it for, is if we run into maybe negative 50 along the line, like along the road, instead of actually dealing with negative 50, we'll just add 360 and do 310 instead. And it'll just become easier to work with. It's a little bit more clear that it lies in quadrant 4. It's probably no, that's probably roughly where it is. Because remember, this is 0, 90, 180, 270, wrapping around to 360. So negative 50 said, okay, I went this way. 310 said, okay, I went this way. But in both of these situations, I got the exact same angle, like placement-wise. Now, if I want another positive angle, I'm just going to add 360 again. So now I'll take 310, and I'll add 360 again to that. Let me go ahead and write it over here. So now I'm going to take 310, and I'm going to add 360 again. And that's going to give me 670. So what's happening with this one is it's actually wrapping around the circle an extra time. So this one still starts at 0, it wraps around all the way to 360, and then it keeps going. And it's positive, so it went counterclockwise. But it still ended up in the exact same spot. So it's still coterminal because it's actually the same angle, but it's a slightly different angle because it's been wrapped around a few times. Now, if you notice with this one, when you started with this 360 and you added it one time, that meant that K in that situation was 1, since you added it once. In the next situation, since we technically added 360 twice to negative 50, that would make our K 2. So in my math lab, what they're going to tell you for this one is they're going to say to do negative 50 plus 360 times 1, and that gives you 310. And then they're going to say, then take negative 50 plus 360 times 2, and that's how you'll get 670. Both of these are correct. It's just one way is using the formula a little bit more like to the T, whereas we're more so just kind of using the idea of coterminal. Now if we want to find negative angles. So these were my positive angles. So let's go ahead and do my negative ones. So for my negative angles, I should subtract 360 so that I get a negative angle. Negative 50 minus 360 is negative 410. And then if I subtract 360 again, but now I'll just do it from the 410, which technically means I'm doing it twice from negative 50. This will give me negative 770. And those are still the angles that, like, they're still in the same place. It's just we got to them a little bit differently. And I'll show you the, like, more mathy way to write these as well. This would be negative 50 plus 360 times negative 1. The negative because we decided to subtract it. And the second one would be negative 50 plus 360 times negative 2. Because we technically did it twice, so my k is 2. And we did minus, so that's why it's negative. And it's really just all about, like, that k is really just how many times do you want to wrap around the circle? You want to wrap around once? You want to wrap around twice? You know, do we want to wrap around counterclockwise or clockwise? That's really all that it's measuring. All right, let's do another one. So let's see, I'll write it as, are the following angles coterminal? And for part A, I'll say alpha is equal to measure of alpha. Be a little bit better with my notation. 190 degrees. And let's say measure of beta is negative 170 degrees. I'll leave some space. Part B, I'll do measure of alpha equals 150 and measure of beta equals 880. So I want to know if these are coterminal. Of course, I recommend pausing so that you can kind of work it out yourself, maybe try it out, but I will go ahead and do it real quick. So the way that I would treat this one is I would just see if I can add or subtract 360 and get the other angle. So for instance, if I start with 190, well, if I'm trying to get to negative 170, do I think, should I subtract 360 or should I add 360? Well, I'm trying to get to something negative, so I'm trying to go smaller, so I'm going to subtract 360. And then I would see, okay, if I do 190 minus 360, what do I get? And that happens to give me negative 170. So yes, these are coterminal angles. You could also do it like maybe you started with negative 170 and maybe you add 360 to it. And that'll give you 190. So that's another way to treat this one. The more mathy way of doing it, and probably how my math lab would show you if you look at their examples, is they would say, let's plug it into the formula. So they would do 190 plus 360k equals negative 170. And then they would solve this for k. Now the process of solving for k, I would subtract 190 from both sides. So this gives me 360k is equal to negative 360. If I divide by 360, I'll get k is equal to negative 1. Since k is an integer, we would say yes. Now, if k was not an integer, so for instance, if it was like a decimal or something, or like a ugly fraction, then we would say no, it's not coterminal. But I think just adding or subtracting 360 is way more intuitive. So for sure, pause and see if you can do part B by yourself. But I'll go ahead and do it. So let's see, if I take 150 and I'm trying to get to a bigger angle, so I'm going to add 360. So let's see what I get. 150 plus 360. what does that give me? 510. Okay, so now I'm going to add 360 again, because I need to get even bigger than that. If I add 360 again, I get to 870. Okay, it doesn't look like these are coterminal then, because if I add 360 again, I'm going to get way bigger than 880. So since I can't just add 360 or subtract 360 to get to the other angle, I would say no, these are not coterminal angles. If you do it the more like mathy way and you plug it into the whole formula and everything, you'll see that K is not an integer. So no. And that's if you actually do it like the way I did it in part A, like if you plug them in and solve for K and stuff. Now, whatever you're comfortable with is what I recommend. So if you kind of just like adding or subtracting 360, that works. If you like using the formula, that's fine. I'll tell you the main use for this is like plotting ugly angles. And so let's do a question like that. So let's see, this will be our example 4. Excuse me. So I'll just say determine, well, let me just say graph. Graph the angles. And we'll do a few. So let's do 230. We'll do negative 580. And then I'll do one more. We'll do 1380. So we're going to graph these angles. Pause, see if you can do it yourself. I'm going to draw my coordinate plane. So 0, 90, 180, 270, and then it wraps around all the way to 360. So 230 is going to be between 180 and 270. So I'll put it like right here. And that's the actual angle. And this is in quadrant 3. It is going to be important to us to like label the quadrants and stuff as we go forward. Now, negative 580. The point of coterminal is to deal with stuff like this. Like negative 580 is kind of a ugly angle to deal with. Like I'm going to have to go the opposite way of what I'm used to. I have to deal with negative angles and stuff. Just kind of annoying, honestly. So what we do instead is we just add 360 until we get a positive angle. So if I add 360 to this, let's see what I get. Negative 580 plus 360. That'll give me negative 220. And then I'm still not in a positive angle, but I really want to be. So I'm going to go ahead and add 360 again. And that gives me 140. And that's a way easier angle to work with. So when we go plot it, instead of having to plot 580 and like wrap around the quadrant and all kind of stuff, I can just do 140 instead. And so that's in quadrant 2. Now, if you wanted to do negative 580, you would just be wrapping around the circle more times. So what will happen there is, see how we had to add 360 twice? That means that this wrapped around the circle twice. All right, so let's keep going. 1380. Again, that's a really big angle, and I'm going to have to like wrap around the circle a bunch of times and stuff. Don't want to do that. Instead, we can subtract 360 from this one to get a more manageable angle. If I subtract 360, I'm going to get 1020. Still not super manageable, so let's go ahead and subtract it again. Then I get 660. Oh, sorry. Let me write my work. Minus 360, so I get 660. Still a little bit too big. I'd really liked it to be smaller than 360, so it plots well. So let's do it yet again. And this is going to give me 300 degrees. And I'll go ahead and plot this. And it plots, I don't know, roughly like right here. And this puts it in quadrant 4. And so B and C are really your biggest uses for coterminal. And that's why I think it's important to be able to understand that it's really just adding or subtracting 360, not necessarily memorizing some kind of formula, you know. Okay, so that is it for 1.1. I will see y'all in the next video. Hope you have a good day. Bye-bye.